In this session, we will do the circuit components, MCQs, multiple choice question related to different circuit components. So, in the question, a battery charger, there's a battery charger plugs into 230 volt supply. So, say this is a supply, main socket is there. This is the main socket, which is 230 volts. And that is having AC current or alternating current. The charger is used to charge a 6 volt DC battery. So there's a battery which we want to charge. For example, there's a battery, or you can say a mobile is there. So we have to use a charger. And say this is a battery which we want to charge, or you can say a mobile we want to charge. So it was 230 volt, we want to convert into 6. So whenever we want to reduce the voltage, whenever we want to change the voltage, what is the component we use? We use a transformer. Transformer is a component, the electrical component which changes the voltage. Working of a transformer in detail we will discuss in magnetism topic, like the second part, which is electromagnetism topic. So the purpose of a transformer is to change the voltage. Input, this is 230 it is taking, and it is converting into 6 volt. So what it is doing, it is increasing the voltage or decreasing the voltage. So this transformer is decreasing the voltage. It take 230, like the charger, the mobile charger which we use, it is having a transformer, and that transform the voltage from high value to low value. So when the transformer convert the high volts into low volts, so we call this type of transformer as step down transformer. Step down means like reducing a voltage. So our mobile charger or charger of the battery, that is a step down transformer. Then we want to convert AC, the alternating current, to DC. So whenever we want to convert AC to DC, the component which we use a diode. Diode is a component which allow the current to move only in one way or convert AC to DC. So to convert this AC to DC, we use diode. And what is the purpose of the diode? Why diode is used? It is used as a rectifier. Rectify means make the current flow in one way, or rectify is the AC, or rectify AC to DC. So what is the purpose of these components? So what is the purpose of a diode? The purpose of a diode is to convert alternating current into direct current, so that current move in one way. So the purpose of the diode is rectification. Then what is the purpose of a transformer? A transformer is used to transform the voltage. But what kind of transformer is this which we are using? Here the transformer is converting a high volts into low volts. So what we call this transformer which reduces the high volts into low volts, we call that as a step down transformer. So purpose of the transformer in this one is step down. Step down means reduces. So which option it matches with? It rectify the AC, means convert AC to DC. The diode and transformer step down the voltage. That's why option A is the right answer. Is it clear, discussion? Then the next question. The diagram shows a potential divider. Potential divider means the circuit which divides the voltage. We call that as a potential divider. The two components are there. This is a variable resistor. This component is called a variable resistor, and here it's called a fixed resistor. Now in the question, the resistance of a variable resistor decreases. So if we reduce the resistance here, if the resistance here decreases, what will happen to voltmeter reading? The voltmeter reading will decrease. And because they are connected in series, if one of the component the voltage decreases, the other component voltage should increase. Because what happened? The total voltage in a potential divider circuit should be constant. So if I say I have a 10-volt supply and 5 volts is here and remaining 5 volts is across the other one. But now what happened? We reduces the resistance of this variable resistor. As a result, when we reduces the resistance of this variable resistor, so the voltage here won't be 5. The voltage might be example 2. So if the 2 volts is here, 2 volts is consumed in this one, because the total sum should be 10. So remaining 8 volts will drop across voltmeter Q. So in the question they mentioned the resistance of a variable resistor decreases. So if resistance decreases, what will happen to voltmeter reading at P? That voltmeter reading will decrease. And in comparison, what will happen to reading of the voltmeter Q? That will increase. So reading on the voltmeter P, that will decrease, and the reading on the voltmeter Q, this will decrease, and the other one will increase. So that's why B is the right answer. Is it clear? That what will happen in a potential divider circuit if we change the resistance of one component? So one side the voltage increases, the other side the voltage will decrease. Total voltage will remain 10, but the voltage division, that's why we call this as a potential divider circuit. So in question 3, after some building work, a house, a bare uninsulated wire, like there's a wire which is not having any insulation or a plastic covering, and it's a live wire, is left protruding from a wall, like it is touching the wall. What is the greatest hazard? What might happen, like if there is a wire which is uninsulated, if someone will touch, what will happen? He will get an electric shock. So C is the right answer, because live wire is there, uninsulated wire, if someone by mistake touch that wire, he will get an electric shock. Is it clear? In question 4, in which circuit does the ammeter shows the greatest reading? So this circuit is having a diode as well. So what will happen? The diode, remember, when the current is passing from the side of the triangle, the diode will allow that current to pass. But if the current is passing from opposite direction, what will be the effect? The diode will block that current. It will stop the current. So current can only pass one way through a diode, the other way it does not, or it cannot pass. So we have to check, because the current in the circuit depends on the resistance. If the circuit is having a high resistance, it will have low current. If the circuit is having a low resistance, it will have high current. So we have to check which circuit will have the low resistance, that will have the highest current. Now how to find? First we'll check, like this is a positive terminal, negative terminal. So when the current, conventional current, move from positive, so this diode will allow the current to pass. And the second diode will also allow the current to pass, because it can pass from positive to negative. Now, so it means both are the effective resistance, because both are used in the circuit. So what is the combined resistance of circuit A? To know the combined resistance, it is the formula is the product divided by sum. So product is 2 multiplied by 3, the two resistance when they are in parallel, divided by sum of the resistance 2 plus 5. So 2 multiplied by 3, that is 6, divided by 7. So 6 by 7 will give us 0.85. So resistance of this circuit is 0.85. Now we have to check the circuit which, because the ammeter shows the greatest reading, means the current should be maximum. So the circuit which is having the least resistance will have the maximum current. So we have to check which circuit is having the least resistance. So circuit A having a resistance of 0.85 only. When we check circuit B, so current cannot, when the conventional current will move, it cannot pass through this diode because it is in opposite way. As I mentioned, if the current is coming from the side of the line, it will block that current, so there will be no current here. So the remaining, all the current will pass through this component. So the only active component here in the circuit is 3 ohm. So what is the total resistance of the circuit? The total resistance or effective resistance is only 3. Why not 2? Because 2 is not, 2 is having like overall, it's not allowing the current to pass. So if it's not allowing the current to pass, so it is not an effective. When we check circuit C, so this diode will block, other diode will also block because the current cannot pass through from direction of the pause or the line. So here, if the current cannot enter, like there's no current in the circuit, so what will be the reading? Reading on of the ammeter here will be 0 amperes. When we check D, when the current is passing, only this will allow the current to pass. The other, the bottom component diode does not allow because it is coming from the side of the pause, like the line, so it won't allow. So the effective resistance here, this circuit has no current because it completely blocked. And what about this one? It is having a 2 ohm resistance. So the question is, which circuit shows the highest reading of ammeter, or which circuit is having the highest current? So the circuit which is having the least resistance will have the highest current. So when we check A, B, C, D, we'll find A is having the least resistance. So that's why maximum amount of charges or current will pass through. Is it clear, this question? Then another circuit, the diagram, this is when two resistors are connected in series, we call that as a potential divider circuit. So the diagram shows the electric circuit when rectangle with an arrow, that is LDR, light dependent resistor. And what happened for LDR? The LDR resistance is inversely proportional to light. If we have more light, then it will have a lower resistance. So greater light intensity or greater amount of light, the resistance of LDR resistance will decrease. So we have an LDR and a fixed resistor. Now the light falling on the light dependent resistor increases in brightness. So if the increases in brightness, what happened to resistance of LDR? That resistance will decrease. So if the resistance of LDR will decrease, what happened to voltage across LDR? The voltage across LDR will also decrease. Less energy will be used. And whenever two components are connected in series, if one component the voltage decreases, the other component voltage should increase. Because the total sum of the voltage should be same. So if I say this is V1, this is V2 and total is V. So V is equals to V1 plus V2. So V1 voltage across LDR is decreasing. The voltage across the fixed resistor should increase. And what about the current in the resistor or current in the circuit? The current in the circuit depends on the combined resistance as they are in series. When two or more components are connected in series, the combined resistance is a sum. If this is R1, resistance is R1 and this resistance is R2. So when two components are in series, the combined resistance is a sum of individual. So R is equals to R1 plus R2. So what happened as R1, because if there's more light intensity, so R1 decreases, resistance of LDR decreases. If resistance of LDR decreases, what happened? R2 is a constant or a fixed resistor. So sum of the resistance will also decrease. As the sum of the resistance decrease, the resistance and current in the circuit are inversely proportional. So if the circuit resistance decrease, the current in the circuit will increase. So when we check which option is correct, number one, what happened to resistance of LDR? So if more light is there, resistance of LDR should decrease. If resistance of LDR decreases, the total resistance of the circuit will also decrease. So the current in the circuit will increase. And if the current, and what about the voltage division? Because if two resistors are connected in series, if one, the component which is having a low resistance, that will have less voltage, and in comparison the other component will have a high volts. So voltmeter is across the fixed resistor. So across LDR the voltage is decreasing, so across the fixed resistor the voltage should increase. So it matches with option B, that the resistance of LDR should decrease as there is more light. The current in the circuit should increase because there is low resistance, and the reading on the voltmeter should also increase, which is across the fixed resistor, as less voltage across LDR, so more voltage across the fixed resistor. So the diagram shows two linked circuits are there when the bell is switched on. The conditions are altered and only one pair of a condition causes the bell to ring. So first, this is a LDR, light dependent resistor. So this is a LDR we call light dependent resistor, and this one is a thermistor. What is the effect of light on this? If we have more light, the resistance will decrease. Or if we increase, and what is the effect of thermistor? What is the effect of heat or temperature? So if we have high temperature, resistance of thermistor will be low. We want the current in the circuit, so we want to reduce, what we want to reduce the resistance of LDR, and we want to reduce the resistance of thermistor, because if they have low resistance then the current can pass. So if the current passes through, this is electromagnet, it will behave like a magnet, it will magnetize, and as a result, when it is magnetized, it will attract the other part of the switch, and when it attract the other part, it will come in contact, and the bell will produce the sound. So we want the resistance of LDR and we want the resistance of thermistor to be lower, because when they have low resistance, then there will be a current in the circuit, and when there's a current in the circuit, this is called a relay. So relay is an electromagnetic switch which close automatically when there's a current, so the other circuit will work and the bell ring. So what we should do, we want to reduce the resistance of LDR. So if I want to reduce the resistance of LDR, it means I should increase the amount of light. So more light, less resistance. And what about thermistor? I want to reduce the resistance of a thermistor. So if I want to reduce the resistance of a thermistor, I should increase the temperature. So we should increase the temperature and we should increase the light intensity. So they, both components will have low resistance and there will be a current in the circuit which cause this relay to work. So which pair cause the bell to ring? So if we use a bright light, like more light, and we use a high temperature, the bells start to ring. So A will be the right answer. The truth table for a logic gate is shown. Which type of logic gate is this? So if we apply, like if this was an AND gate, this is a symbol for AND gate. If this was an AND gate, this is input 1. This one is input 2. And this one is output. So if this was an AND gate, how we get the result for the AND gate is by multiplication. By multiplying the two inputs, we'll get the result, output. So we'll check whether we are getting a right result. 0 multiplied by 0. So 0 multiplied by 0 is 0, but here it is written 1. So it means it is not an AND gate. Then we check the second option. Second option is NOR gate. What is the meaning of NOR gate? It's a combination of OR and NOT. That's called NOR gate. And how we get the result of the NOR gate? This is input 1, input 2, and output. How we get the result of the NOR gate? It is, first we do addition, first we add and then invert. Like make the output as invert, opposite. So first we add and then we make the output invert. So 1 plus 0 plus 0, that is 0. And what is the opposite of 0? Because in a binary, there are like opposite of 0 is 1 and opposite or invert of 1 is 0. So 0 plus 0 is 0 and then we invert, so it will make it 1. That's right. Then when we check 0 plus 1, we have to check all. 0 plus 1, that is 1. And then we invert, so it becomes 0. So that is also correct. 1 plus 0, that is 1. And we invert that, so it becomes 0. 1 plus 1 in binary, 1 plus 1 is not 2. In binary, 1 plus 1 is 1. Like if there's their input current, the output will be there. And then we invert. So it means it follow all the logic of a NOR gate. So it is a truth table of NOR gate. If it was a NOT gate, it cannot be NOT gate because the NOT gate is having only one input and one output. So in the question, there are two inputs and one output, so it can never be a NOT gate. And to be an OR gate, we get the result by addition. For NOT gate, we get the result by inversion. For AND gate, we get the result by multiplication. And for NOR gate, we get the result first by addition and then by inversion. So when we apply, C can never be an answer because NOT gate is having one input and one output. It does not have two inputs and one output. That's why it is totally wrong. And when we check, if it was an OR gate, 0 plus 0 should be 0, but it is not OR gate. If it was an AND gate, 0 multiplied by 0 should be 0, but it is not an AND gate. So we are left with only NOR gate. So I can check all the options and work out which one it matches with. In this circuit, a component X is automatically protect the wire from overheating. So if too much current is there, automatically it will switch off. Automatically the circuit will close. So what we can use here, what are the component automatically cut off? It can be either a circuit breaker, because circuit breaker, if too much current is there, automatically it switch off and we have to reset. Or it might be a fuse. If too much current is there, the fuse will melt and we have to replace the fuse. But it cannot be switch cannot work automatically. That's why B is the right answer. For switch, we have to change its state, like we have to either switch on the device or off the device. But automatically the component which cut off if there is a too much current are circuit breakers and fuse. Circuit breakers use electromagnetic effect or magnetic effect, whereas fuse use the heating effect of the current. But normal switches which we use, we have to be there to change the state. It cannot automatically, it cannot switch on or off. In this question, the diagram shows a circuit which is having a diode. So remember, when the current is passing from a side of, look, diode, easy to remember the working of a diode. Diode is actually like a combination of symbol play. This is like on a video, if we want to play a video, this is a symbol. And if we want to stop a video or pause a video, this is a symbol. So if I combine them together, it will become play and pause, and that is actually a symbol for diode. So if the current is coming from the side of the play, that play means allow here, so diode will allow. But if the current is coming from the side of the pause, diode will block, does not allow, stop that. So in the question, which lamps light when the switch is closed? So when we close the switch, what is the direction of the conventional current? It is always from positive to negative. So current start to move. So this diode will allow, because it is coming from the side of the play. Now we have two options, diode up or down. Which diode will allow the current to pass? The top one or the bottom one? Which diode allow the current to pass through it? Which of the diode will allow the current to flow through it? Which is lamp 1 or lamp 2? So look, for lamp 2, it is coming from the side of the pause. So if the current is coming from the side of the pause, the diode will block, does not allow. But for the other one, that it is coming from the side of the play, the diode will allow. So this is how the current will pass through. There will be no current passes through lamp 2. All the current will pass through lamp 1. So which lamp will light up? Only lamp 1. So A is the right answer. So even if it is drawn other way around, like if they draw the diode in this manner, so even a diode is drawn in this manner, if the current is coming from the side of the block, the wall, diode does not allow, block. If the current is coming from the opposite side, the diode will allow that current to pass. The diagram shows pair of circuit containing a logic gate. In which circuit does the lower circuit of a pair not behave in same way as the upper? So we have to check. We have to check, like example, how to check this. If I say this is 0, and first thing you have to identify the circuit using the symbols. You should be able to identify the logic gate. If this is there, it is a NOT gate. NOT gate means it is an inverter. It invert. How to get the result is by inversion. If 0 is there, make 1. 1 is there, make 0. If there was, this is called a NAND gate. And how to get the result of the NAND gate? First multiply and then invert. Like multiply the inputs and then invert. Then we have a NOR gate. So how to get the result of a NOR gate? First add and then invert. Then it might be an AND gate. AND gate, it is by multiplication. And then it might be an OR gate. For OR gate, to get the result, we simply add. So addition will give the result of OR gate. Now we'll check. The question is, in which one circuit in the bottom does not behave like same as the circuit at the top? So if I take 1, it passes through inverter, it becomes 0. And if I take 1 here, this 1, 1 and 1. What kind of gate is this? It is a NAND gate. How to get the result of a NAND gate? First multiply the inputs. 1 multiplied by 1 is 1, and then passes through inverter, so it will make 0. So result of the first circuit and the result of the second circuit are same. So it means this is not an answer. In the question they are asking which is not behaving at the same way. And I can also I can take 0 as well, the first value. I can take this as 0, so 0 will make it 1. and here 0, so 0 0. Again it is a NAND gate, so 0 multiplied by 0 is 0, and then it make an inverter, so 1 is there. So both up top and the bottom both are behaving in the same manner. So here they are behaving in the same manner. When we check B, example, if I take 1 1, this is a AND gate, we get the result by multiplication, so 1 1 is 1. When I take 1 1 here, this is a NAND gate, so 1 1 is 1, that passes through inverter, make it 0. Then this 0 and 0, again another NAND gate, 0 multiplied by 0 is 0, and then passes through the inverter, it will make it 1. So when we just check if both inputs are 1, output is also 1 for both circuits, so it means B is also acting in the same manner. And I can check with other options, like I can check with 1 0 as well, I will get the same result. So if this is 1 and the other one is 0, 1 multiplied by 0, that is 0. Here 1 and 0, so 1 multiplied by 0, that is 0, make it 1, inverter. And then this is 1 1, 1 multiplied by 1 is 1, but inverter is there, so it make it 0. So it's inputs and outputs, if we use any input, the output will be same for both circuit. When we check option C, example 1 and 0, this is a OR gate, we get the result by addition. So 1 plus 0 is 1. And here 1 and 0, when I use, this is a NOR gate, 1 plus 0 is 1, and inverter will make it 0. So this will be 0 0. And now this is a NAND gate, how we get the result? Multiply and then add. So 0 multiplied by 0 is 0, and then passes through inverter, it will make it 1. So you can see it is also having the same result. When we check this one, so example, this is 1 and 0. So 1 multiplied by 0, that is 0, because it is a AND gate. We get the result for AND gate by multiplication or by product. Here first one is a NOR gate and second one is a NOT gate. So I select 1 and 0, 1 plus 0, because in NOR gate we first add and then invert. So 1 plus 0 is 1, and then passes to inverter, it will make 0. And then inverter, what it will do, inverter inputs, like converted the input to opposite. So if it input is 0, the output will be 1. So in circuit D, the results of the first circuit are different from the result of the second circuit. So that's why D is the right answer. So for this question to answer, you need a practice. You should remember the circuit symbol, and you should also remember that how to get the results of different logic gates. Because without memorizing the circuit symbol as well as their logics, you won't be able to solve this. A student set up a circuit containing a battery of 2 cells and 3 lamps. Look, which is the correct circuit diagram. So this is the first cell, negative. So negative is small, positive is big. Then next to that is another negative and positive. Then there is a bulb. So what is the circuit symbol for the bulb? So this is a circuit symbol for the bulb. Then this is connected to another bulb, and with this bulb there is another connection with another bulb, and then it is going back. So which one it appear? Like we should have one lamp next in series with the other two. So when we check with option A, it matches with option A, because 2 cells in series, first bulb is there, this is the first bulb, and next to that 2 bulbs are there which are in parallel. So you can see 2 bulbs in parallel, and then the connection is going back to the battery. What about this one? If this was the right answer, it means that 2 bulbs should be in series, like these 2 bulbs should be in parallel, in series, So it should be like this, two bulbs which are connected in series and there is another in parallel to them. But this bulb is only in parallel to the second. So that's why B is not the right, C is not the right. C means all are in parallel, D means all are in series, A means two in parallel and one in series. And B means two in series and one in parallel. So when we check with the circuit which is shown, it matches with A. Is it clear discussion?